Hi, everybody. It's Professor Mitchell, continuing with Chapter 3. Today, we're looking at Section 3.3 on intercepts. In this section, we will identify intercepts of a graph a linear equation by finding and plotting intercepts, and finally, identify and graph horizontal and vertical lines. And this is part of the same student learning outcome. We are constructing graphs of linear functions. All right, so when we talk about intercepts, there are two types of intercepts. The X-intercepts of a graph are the points where the graph intersects the x-axis, and the Y-intercepts of a graph are the points where the graph intersects the y-axis. So in this example, they're asking us to identify the intercepts. Here's the graph. Obviously, this is not the graph of a straight line. So first, think about how many x-intercepts are there. There are three, right? One here, and one here. So the x-intercepts are the points -4, 0, -1, 0, and 1, 0. Notice I've written them as ordered pairs. When you're doing online homework, be careful to read the directions. Make sure that if they ask for an ordered pair, you give an ordered pair, or if they just ask for a number. For example, for this one, they might just want -4. I've noticed that different books are inconsistent about this. Anyway, just read the directions. They'll tell you exactly what kind of answer they want. All right, and then how many y-intercepts are there? There is only one y-intercept, right? It's this point up here, which is the point 0, 4. So one thing I notice, especially with the x-intercepts, is that the y-coordinate is always 0. Which is not surprising. Any point on the x-axis has a y-coordinate of 0 because you're only moving left or right. You're not moving up or down. All right, so not too hard to see that to find x-intercepts, we should set the y-coordinate equal to, or we should set y equal to 0 and solve for x. Similarly, to find y-intercepts, we should set x equal to 0 and solve for y. All right, so in these next two examples, we're going to graph the linear equation by finding and plotting the intercepts. And I need to give you a heads up here. In the online homework, if they ask you to graph it using the intercepts, you have to graph it using the intercepts, otherwise it will mark it wrong. All right, in case you haven't been into the online homework yet to see how lines are graphed, use something called the line tool, where it asks you to plot two different points and then it just automatically draws the line. So in a problem like this, the 2 points that you plot would have to be the intercepts, assuming there are two intercepts. All right, so let's go over to the tablet. All right, so here is the first problem. X minus 2y equals -8. We want to graph that using the intercepts. So remember, really graphing using the intercepts is a special kind of point plotting method. It's just that you're finding two specific points. Remember, to find the y-intercept, you set x equal to 0. And to find the x-intercept, you set y equal to 0. Okay, let me think. All right, I guess I'll do my work over here. Okay, so when we set x equal to 0, we get 0 minus 2y equals -8, which means -2y equals -8. Dividing both sides by -2, you get y equals 4. All right, and then for the x-intercept, I'm going to set y equal to 0, and that's going to give me x minus 2 times 0 equals -8. And that just gives me x equals -8. All right, so again, if you're doing this on the online homework, those are the 2 points that you would plot. However, I always think it's a good idea to grab one more point as a checkpoint. So this part would just be for doing it on the paper. Let's see, I have y equals 4, y equals 0. So as a check, why don't we use y equals 2? And I'll do that over here. So that's going to give me x minus 2 times 2 equals -8. X minus 4 equals -8. Add 4 to both sides, you get x equals -4. So I will plot those 3 points and make sure they all line up. Now notice the grid that I'm using in this problem doesn't have anything marked off, and I felt like I had to do it that way because the one that I usually use only goes down as far as x equals -6, I think. So it would have been off the grid. Okay, so that's fine. I'll just mark off 1, 2, 3, 4. Do your best to make those, you know, as evenly spaced as you can. And then going this way, I'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 0, 4. We have -8, 0. And then as my checkpoint, I used -4, 2. And it looks to me like those points line up. It's not going to be perfect because I made these, grid lines freehand. Speaking of freehand, I think I'm going to live dangerously and just try to draw this line without using a straight edge. That's not too bad. Okay. All right, so that is a graph of the line x minus 2y equals -8 using the intercepts. All right, the next example is y equals -2x. And again, we're supposed to graph it using the intercepts. Okay, so this time I'll start with the y-intercept. When x is 0, that gives me y equals -2 times 0, which is y equals 0. And the reason I'm saying is because the y-intercept also turns out to be an x-intercept, which means if we're graphing a straight line, the intercepts, there's only going to be one total intercept. And they do this sometimes. So I did the best I could to graph it using the intercepts, but I'm going to need at least one and ideally 2 other points. So let's say we go with 1 and 2. Oh, I think we can just do this right here. When x is 1, y is -2 times 1, which is -2. And when x is 2, y is -2 times 2, which is -4. So that gives us not only 0, 0, but also 1, -2, and 2, -4. And those points look like they line up. So this line is going to look something like this. All right, pretty happy with how that one turned out. All right, so let's go back to the presentation. This is a pretty short section. I think there's just one more example. Oops. Oh, okay, so back to the different methods for graphing linear equations. Using the intercepts is the second of the 3 methods we will learn for graphing linear equations. In the last section, we talked about the point plotting method. Now we're talking about using intercepts. And I believe in the next section, we're going to see one more method. The suspense is unbearable. Oh, that's terrible. Okay. All right, so here's the last example. We're going to graph the linear equation y equals 5. Notice there's no x in that equation. All right, here we go. So we did an example that was kind of like this a section or two ago. I think it was in the last section. Since there's no x, but y equals 5, that means that y is always 5. X can be whatever it wants to be. X could be 0, x could be 1, x could be -2. All right, so if I plot those points, 0, 5, 1, 5, and -2, 5, you see what kind of line this is making. This is a horizontal line. All right, so if I remember correctly from the last section, I think the example we went over was x equals -1. That turned out to be a vertical line. And now the line y equals 5 turns out to be a horizontal line. And there is a pattern to that, which we will explore more in the next section or two. The graph of x equals c, in other words, x equals a number like x equals -1, is a vertical line with x-intercept c0 and no y-intercept. You know what? Scratch that. Let's just leave it like this. Vertical line with x-intercept c0. So that example that we saw in the last section, x equals -1, it had an x-intercept at -1, 0. And the graph of y equals c, like y equals 5, is a horizontal line with y-intercept 0, c. In this case, it was 0, 5. And we will talk more about vertical and horizontal lines in the next section or two. But in the meantime, that's going to do it for section 3.3. We'll see you next time.